Good morning, students. Today we'll start a new chapter which is called equilibrium, and this chapter is the last chapter of your first book. So we'll do this chapter equilibrium. Now first time you should know what is equilibrium. Actually equilibrium means it is a state of a process in which the properties like temperature, pressure, concentration, this type of properties do not change with time. I mean, when it gains the equilibrium state, when the system gain the equilibrium state, after gaining the equilibrium state, there will be no change of concentration, there will be no change of temperature, pressure, etc. Of the system with the passage of time. Now, first time I will give you the definition. Equilibrium represent a state of a process in which the properties like temperature, pressure, concentration, etc. of the system or of the process do not show any change, with the passage of time. So like this you can write the definition of equilibrium. Equilibrium means nothing, it is a state in which state of a system in which the properties like temperature, pressure, etc. they do not show any change with the passage of time. For example, this is a container, and the container contain some amount of water, and in that water one piece of ice is present. It's a piece of ice, and this is water. Normally, when a piece of ice is placed in water, the ice will melt and it will convert to water. But if the ice is placed in water at 0 degrees Celsius, if the system is present at 0 degrees Celsius, then the amount of water will remain same inside the container. I mean, ice will remain same, water will remain same. The amount of water, the amount of ice will remain same. I mean, there will be no change of concentration, there will be no change of their amount. Now, why at 0 degrees Celsius the amount of ice, amount of water remains same? Actually, at this temperature, the system will get the equilibrium state. Freezing point of water is 0 degrees Celsius. So at 0 degrees Celsius, the water will convert to ice, and at the same time, the ice will convert it to water also. And the amount of ice convert to water is equal to the amount of water convert to ice. I mean, at 0 degrees Celsius, the ice will melt. Similarly, the water will solidify, and the amount of solidification and amount of melting of ice will remain same, and that is why the amount of ice, amount of water remain same. And this is called the equilibrium state between the solid and the liquid. And this type of equilibrium is called solid-liquid equilibrium. Have you got it? So this is called equilibrium state. So when it gain the equilibrium state, the amount of the substance will remain same. Amount of water will remain there. Amount of ice also will remain same. You don't get any change. But in normal temperature, when you keep one ice in water, then the ice will melt. It will convert to water. But if you place it at 0 degrees Celsius, the amount of ice will remain there. That means it will gain the equilibrium state with the liquid. Similarly, suppose this is a container and the container is closed and it contains little amount of water. You know, at normal temperature also water undergo evaporation. So automatically water undergo evaporation. But since the container is closed, the evaporate molecule cannot go out. That is why the evaporate molecule comes at the top position of the container like this. Now as the number of evaporate particle increases, then what happens? They again undergo condensation. I mean both evaporation and condensation takes place. For simple example, suppose there is a glass of water. In that glass of water, if you cover it by using a plate, after half an hour when you remove the plate, then you can see some water bubbles inside in the plate. Why? It is due to this condensation. So when some liquid is placed in a closed container, then the liquid undergo evaporation, and since the container is closed, the evaporate molecule cannot go out. Then as the evaporate particle going on increasing, they start to undergo condensation, and what happened? At a time both evaporation and condensation will take place. And when these two processes going on at a time, the amount of evaporation and amount of condensation at a time it becomes same. And when the rate of evaporation and rate of condensation becomes same, then the amount of vapor, amount of liquid will remain same inside the container. And that is the equilibrium, that is called the equilibrium state between this liquid and the vapor. I mean this is called liquid vapor equilibrium or liquid gas equilibrium. Have you got it what I am saying? So when you keep some amount of liquid in a closed container, the liquid undergo evaporation. Due to closed container, the evaporate molecule cannot go out. As the number of evaporate molecule going on increasing, they start condensation. So initially evaporation takes place, after that the condensation will start. But at a time, the amount of evaporation, I mean rate of evaporation and rate of condensation become same, and that is called the equilibrium state of the liquid. And at that equilibrium state, the amount of liquid, the amount of vapor will remain same inside the container, and that is also represent a equilibrium state between liquid and vapor. So these are the example of the equilibrium state. So when a system gain the equilibrium state, then the concentration of the substances, the pressure, the temperature, everything will remain same with the passage of time. So there will be no change of concentration, pressure, temperature. So this is about the equilibrium. Now, do you know what is reversible reaction? Do you know what is reversible reaction? There are some reactions which are said to be reversible reaction. I mean those reactions which takes place in both forward and backward direction. That type of reactions are called reversible reaction. All reactions are not reversible. Some reactions are found to be reversible. For example, this is what ammonia NH3. When ammonia undergo decomposition, then it produces nitrogen gas and hydrogen gas. This reaction, this sign represents the reversible sign. This is called forward direction and this is called backward direction. So when a reaction takes place both in forward and backward direction, that type of reactions are called reversible reaction. Here ammonia, when it undergo decomposition, it produces nitrogen and hydrogen gas. Similarly, when nitrogen and hydrogen gas react, it can form ammonia. I mean from both sides the reaction can take place, and this type of reactions are called reversible reaction. The reaction which takes place both in forward and backward direction, that type of reactions are called reversible reaction. There are so many reactions you will get in book which are reversible in nature. Now, see if this reaction, when ammonia undergo decomposition, it produces nitrogen and hydrogen, that is called the forward direction. And when the amount of nitrogen and hydrogen increases, I mean when more amount of product is formed, then they undergo backward direction reaction also. I mean both the reaction will take place. First time forward direction takes place, after that the backward direction will start to produce ammonia. Now initially the rate of forward reaction is more, but as the time proceeds, backward reaction will start, and at a time the rate of forward reaction and the rate of backward reaction become same, and that is called the equilibrium state for the reaction. I mean when the rate of forward reaction and the rate of backward reaction become same, then the reaction is said to be at equilibrium. Normally first time forward reaction takes place, first time you don't get the backward reaction, but as the time proceeds, backward reaction will start, and at a time what happen, the amount of forward reaction, I mean the rate of forward reaction become equal to rate of backward reaction, and at that moment the reaction will gain the equilibrium state. So when a reaction is said to be equilibrium, this sign represent reversible, but it represent equilibrium also, but reversible means it do not represent the equilibrium. The reversible reaction will be at equilibrium when the rate of forward reaction become equal to the rate of backward reaction. That is why to gain the equilibrium state, the reaction will take some amount of time. Immediately you don't get the equilibrium state. So that is called the chemical equilibrium. I mean when the rate of forward reaction become equal to the rate of backward reaction, then the reaction is said to be at equilibrium.